So moving on, we're going to talk about how the energy levels determine the shape of the table. So here are the first 20 elements and their energy levels. And one of the things that we want to point out is the number of protons around the nucleus. So the first energy level, if you look at the rows, so these are rows, this is row 1, this is 2, 3, and 4. So they go across and they're arranged in sequence by the atomic number. Obviously, 1, 2, 3, 4, 5. You can see so on and so forth how that works. And they increase going from left to right. If the number of electrons equal the number of protons, the number of electrons also increases left to right. So again, protons and electrons equal each other and they increase going left to right. That also tells the number of energy levels that we have. So if you look at the chart, the first row has 1 energy level. You see that it's just that gray. There's nothing that goes with it. The second row has 2 energy levels with different electrons in them. The third row has 3, and the fourth row has 4 energy levels. So electrons and energy levels. Every atom contains different energy levels that can hold a specific number of electrons. So we're going to talk about a possible scenario that might make more sense to you, showing how they fill each position until they're full, and then they move into the next energy level. So to picture this, we're going to use chairs and people as electrons. So people fill rows of chairs in an auditorium, and they sit side by side until each row is full, and then they have to move on to the row behind them. So once the electrons fill their row or their energy level, they have to move to the next energy level and fill that up. Electrons begin filling the lowest energy level, which is closest to the nucleus, and then move on to the higher energy levels, which is further from the nucleus. So if we're looking here, the first energy level can only take 2 electrons. So if there's any more than that, so any number higher with an atomic number of 3 or higher has to be in the next row. And that's what you can see on our slide of the periodic table, that they're in the second row, which has 2 energy levels. So if they have 2, they move to the next row and they fill that up. So energy levels hold different number of electrons. First, like I said, holds 2. Second holds 8. The third holds 18. And the fourth holds 32. So based on the atomic number, which again equals protons and electrons, determines how many energy levels they have. So let's look at sodium. Sodium is our atomic number of 11. If you look at your periodic table, you'll know that. So let's see how many energy levels sodium has and which row it falls in. So we fill up our first level. Here's our 2 electrons right here. We then move to the second energy level and sit and fill 1, 2, 3, 5, 6, 7, 8. So 2 plus 8 is 10. Since our atomic number and sodium is 11, we move to our third energy level. We're going to stop today's lesson there, and tomorrow we're going to look at how it gets a little more complicated, starting with potassium, which is atomic number 19.